part 2 of the video on indices. And we begin from where we stopped the last time, which is our negative index law. Negative index law. Negative index law. If you remember from last class, it says that a raised to the power of minus 1 is written as 1 over a raised to the power of 1. Also, we have something like a raised to the power of minus 2 is written as 1 over a raised to the power of 2. A raised to the power of 2. Now, let's imagine that we have a fraction, like something like this. Let me say a over b raised to the power of minus 2. So the simplest way to go about this is what is inside this bracket is a fraction, and we want to remove this negative. So in fraction, once we have what is here in fraction, to remove this negative, we just flip what is in the numerator for the denominator and what is in the denominator for the numerator. So what I just mean is to remove that fraction, to remove that negative, just have b over a all raised to the power of 2. B over a, this one is a over b. So we're removing the negative. Since it's a fraction, just flip that fraction. That means it becomes b over a to the power of 2. And this also means since b over a is inside this bracket, so if you want to distribute these two, distribute for these both elements inside that bracket, that means I'm saying it to be b squared divided by a squared. So that's that. So that means when we have a single variable or a number raised to the power of negative index, this is how we go about it. But when we have it as a fraction and we want to remove that negative value, just flip that fraction and the negative will disappear. So let's go to the last part of the law. Now this one we say is a fractional index law. What we are saying, and that means when the power is a fraction. If I say x raised to the power m over n. But let me first start with the simple one. If I say x raised to the power 1 over n. This gives us that is a square root of n x all raised to the power of 1. If you have a power or the index in form of a fraction, you see the numerator of this fraction is 1 and the denominator is n. So you just put, depending on the value of this n, just put this in the root of that n for the value of x all raised to the power of 1. Anything raised to the power of 1 will retain that n. So this is just simply the same thing as having it as square root of n of x. What am I saying? We have something like 9 raised to the power of 1 over 2. I'm saying I will have it as square root. Since the numerator here is 2, so it becomes square root of 9. And the square root of 9 is 3. The other way to go about this is to find a way to write 9 as an index. If I say the other way to go about this is, if I say 9 raised to the power 1 over 2, I can say 9 can give me 3. The index of 9 is 3 raised to the power of 2. Don't forget there is a power of half there before, so that will be the product power law times 1 over 2. So that's 2 times half, that would be 1. So it is 3 raised to the power 1, and we still have 3. So it's a two way to go about it. Either you use this law, or you express our 9 as index. The same thing if I say 27 raised to the power 1 over 3. What I'm saying is, since 3 is the denominator here, I'm saying it is cube root of 3 of 27. And the cube root of 27 is 3. The other way to go about this is to saying that when you have 27 raised to the power 1 over 3, I can rewrite 27 as 3 raised to the power 3. I'll say 3 raised to the power 3 times 1 over 3. You see, these are product powers law. That means the powers are multiplying themselves. So 3 times 1 over 3, that will be 1. That's 3 raised to the power 1, and that is 3. So that's the first part of this fractional index law, when you have the power to be 1 over a value. 1 over. Also, but when we have it in such a way that it is not, if the numerator is not 1, that means I'm saying when I have something like this, we are still going to follow the same thing when it's x raised to the power m over n. Now the numerator here is not 1. So what we have here is saying that we are following the same process, but what's changed is because the numerator here is 1, say it's raised to the power 1, but this one has changed to m. So it will be the root of what that n is of x. Everything will now raise to the power of m. Now here it's just like our m here is 1. But here we are saying m can be another thing apart from 1. What am I saying? You were saying 9 raised to power, let me say 3 over 2. What this one is saying by applying the law is, since, don't forget, the denominator is always what is in the root here. Either it is square root or the cube root or anything. Don't forget it's the denominator, not the numerator. So I'm saying because the denominator is 2 here, I say it is 2, the square root of 9, or to the power of 3. Now the square root of 9 is 3. So 3 to the power of 3. So 3 raised to the power 3, that will be 3 raised to the power of 3, and that will give us 27. You can also follow our normal way by writing 9 as an index. You say 9 raised to the power 3 over 2. 9 can be written as 3 raised to the power 2 times, we have a power there before, which is 3 over 2. And this 2, we cancel this 2. So that means we have 3 raised to the power of 3. And that will still give us 27. So anyone who wants to do, by applying the law, will get to the same answer. Now, also, when we are saying, let me look at one example. When we say 81 raised to the power of, let me say 2 over 3. That means I'm saying the cube root. So this one is out. Sorry. This one is 3. Now we say 81 raised to the power 3 over 4. What this one is saying, the denominator here is 4, so to be like 4th root of 81, or raised to the power of 3. So what are the things, the number that you multiply 4 times to give us 81? So that means 3 times 3, 9, 9 times 3, 27, 27 times 3. That's 81. So that means this will give us, the 4th root of 81 is 3. And we have a power of 3 already. So, and this will also give us 27. If you apply the same thing, it still be the same. You say 81 raised to the power 3 over 4 is equal to, 81 can be written as 3 over 4 times 3 over 4 as the power. 4 we cancel 4 here, and we still left with 3 raised to the power of 3. And that will still be 27. So in which way we want to go about it, you will still get the same answer. But don't forget, when you're applying this fractional index law, it's always the denominator that is in that, either it is square root, either it's the cube root or the 4th root, always the denominator. The numerator becomes the power. The numerator becomes the power. So now we want to move to solving some question, like an example question under Waec, just some Waec questions. Now, if you look for example 1 now, and the question is saying that we should evaluate 4 raised to the power of half plus 125 raised to the power of 1 over 3. Everything now becomes a square. Now we should evaluate this. 4 raised to the power of half plus 125 raised to the power of 1 over 3. 4 raised to the power of 2. Now let's take it one by one. What do we mean by 4 to the power of half? Don't forget, this is, since the power here is fraction, it's a fraction index, you can apply a fraction index law. And the numerator here is 1, the denominator is 2. I can say it is the square root of 4 to the power of 1. And the square root of 4 is 2. 2 raised to the power of 1 is still 2. The same thing for our 125 raised to the power of 1 over 3. It's also a fractional index law. You can apply that. The denominator here is 3. So this one becomes a cube root of 125 to the power of 1. And that becomes the number to multiply 3 times to give us 125. That will be 5 to the power of 1. That will still be 5. So we can now go back to evaluate this. And that means 4 raised to the power 1 over 2 plus 125 raised to the power 1 over 3 all square will be 4 raised to the power of 1 over 2 is 2 plus 125 raised to the power of 1 over 3 is 5, 4 raised to the power 2. And 2 plus 5, that's 7, 4 raised to the power 2. And that becomes 49. That becomes 49. 49. That's one day. Let's try another example. Say example 2. The question is saying 2 raised to the power of n equals to y. Now saying find 2 raised to the power of 2 plus n over 3. That means we should find this in terms of y. In terms of y. In terms of y. So if you look at this now, you will see that the power here, we have an addition at the power 2 plus n over 3. 2 plus n over 3. That's an addition at the power. And if you remember from our multiplication law, since we have the same base, our multiplication law now, our multiplication law, we are saying that if you have something that have the same base, x raised to the power of a multiplied by x raised to the power of b, the same thing as x raised to the power of a plus b. And that means I can move from this back to this. I can go from this back to this. And if I use this law for this now, I can say that 2 raised to the power of 2 plus n over 3, since it is addition, it will be a multiplication. That means it can be 2 raised to the power of 2 multiplied by 2 raised to the power of n over 3. So I can simplify it this way. 2 raised to the power of 2 multiplied by 2 raised to the power of n over 3. Now, this can now be simplified for that. 2 raised to the power of 2 is 4. Multiplied by 2 raised to the power. Now, don't forget, we have been given that 2 raised to the power of n is 1. But here we have n over 3. So I can do it as this to separate it as n, 2 raised to the power of n, multiplied by 1 over 3. Now, n here is a power. Multiplied by 1 over 3 is also a power. That's 2 raised to the power n times 1 over 3. That means I can rewrite this n raised to power 2 raised to the power of n over 3. This n over 3 can be written as n multiplied by 1 over 3. That means if I write it that way, I'm saying it to be 4 times 2 raised to the power of n is y. Don't forget, this 1 over 3 is still a power here. It's still a power here. So that means I will say, since 2 raised to the power of n is y, I can say y, and this 1 over 3 is still a power, is 1 over 3. So this can now be 4y raised to the power 1 over 3. And if you want to apply our fractional index there, you can say it is 4 times cube root of y. 4 times cube root of y. You see, this does mean multiplication. And I will write it as 4y raised to the power 1 over 3. I will say 4 times cube root of, because y raised to the power 1 over 3. If I apply my fractional index law there, it will be a cube root of y. It will be cube root of y. Now, let's go to another example. Let's say example 3. This one is saying that G evaluate 0.027 all raised to the power of minus 2 over 3. Now, this is a decimal. And anytime we see a decimal in indices, we must turn it to a fraction. We must turn it to a fraction. So how do we turn a 0.027 to a fraction? If you look at this, this is just our primary or junior class work. To turn 0.027 to fraction, we see that the number after the fraction here, we have 3 digits after the fraction. We have 0, 2, and 7. So that means that becomes 27 over 1000. Because it's 3 digits after the fraction, all raised to the power of minus 2 over 3. Now, don't forget, this is a fraction. Now, 27 over 1000. And the power here is a negative value, negative 2 over 3. Now, the first assignment here is to remove this negative. And don't forget, from our fractional index law, in which we have a fraction in the bracket, to remove this negative is just to flip this fraction. So for me to remove this negative, I will just say is that 27 over 1000 becomes 1000 divided by 27, all raised to the power of 2 over 3. So the negative has been removed by flipping this fraction, by flipping the fraction. Now, to now simplify this one further, this is now a fractional power. A fractional power. The numerator here is 2, the denominator here is 3. So that means what I'm saying is that this now becomes a cube root of 1000 over 27 all to the power of 2. So what's the cube root of 1000? A number we multiply 3 times to get 1000 is 10. And the cube root of 27, that means the number to multiply 3 times to give us 27 is 3. All square. And don't forget, I say when you have something inside a bracket, either you see now this one is 10 divided by 3. Please don't leave your answer in decimal. This is indices. Your answer must be in fraction. So it's the same thing as saying 10 square over 3 square. Both of them will share the power. And 10 square is 100 and 3 square is 9. So the answer is 100 over 9. 100 over 9. That's the answer, 100 over 9. Let's look at another one. Now look at this. I have 16 over 250 all raised to the power of minus 4 over 3. Now, we have a negative here too. To remove this negative, we just flip this fraction. And that means this becomes 250 over 16 all raised to the power of 4 over 3. Now, this one becomes a fractional index. But if you look at this, 250 does not have a cube root. 16 does not have a cube root. So if you just say the cube root of this all to the power of 4, that's where we get stuck. Because both 250 and 16 does not have a cube root. But what can we do? Is it possible for us to reduce this to a lowest term? To reduce it to its lowest term. So if you reduce it to its lowest term, what can go in both? I think 4 can go, 2 can go here, that's 125. 2 into 50, that's 125. So 2 go here, we have 125. 2 go here, we have 8. That's 125 over 8, raised to the power of 4 over 3. I think 125 can have a cube root. 8 can have a cube. You can now apply the fractional index law, saying the cube root of this 125 over 8, all raised to the power of 4. So the cube root of 125, what are the numbers we multiply 3 times to get 125? That's 5. And the cube root of 8, that's 2, all raised to the power of 4. So this is telling us 5 raised to the power of 4 divided by 2 raised to the power of 4. And that will give us 625 over 16. Please don't let us forget from here, this one now helps us to know that we can reduce to a lowest fraction depending on our denominator here. Depending on our denominator here. Now, let's move to another example. Now, this one is saying that we should simplify 2 raised to the power of n minus 1 multiplied by 27 to the power of n plus 1 divided by 81 to the power of n. Now, this is multiplication and division now. And for us to use a multiplication law, that means the base must be the same. But the base here is 3, the base here is 27, the base here is 81. So the first assignment is to make sure that we can put everything in the same base. Since this is 27, I can rewrite 27 as 3 raised to the power of 3, and I can rewrite 81 as 3 raised to the power of 4. As 3 raised to the power of 4. So the best way to go is to just say this one says 3 raised to the power of n minus 1 multiplied by 27 is 3 raised to the power of 3. That would be 3 raised to the power. Don't forget we have a power there before, which is n plus 1. It's multiplying it. Divided by 81 is 3 raised to the power of 4. Don't forget we have a power there before, which is n. Now let's simplify further now. This is 3 raised to the power of n minus 1 multiplied by this will be 3 raised to the power of 3n plus 3. We use this 3 to open the bracket. 3 times n, that's 3n. 3 times 1, and that's 3, divided by 3 raised to the power of 4n. Now for the numerator now, we can apply our multiplicational law. So from what we get there, we can now apply our divisional law to this. So for our numerator, let's apply our multiplicational law. Since they have the same base of 3, that means we can add the powers. Pick one base, that will be 3 raised to the power of n minus 1. We are adding the power plus 3n plus 3. Don't forget we still have our denominator there, 3 raised to the power of 4n. Now if you simplify the power further, that means n plus 3n, that becomes 4n And minus 1 plus 3, that becomes plus 2, divided by 3 raised to the power of 4. So we can now apply our division because divisional law, because the base here is 3, the base here is still 3. So that means divisional law means we subtract the power. So that means 3 raised to the power of 4n plus 2 minus 4n. Now 4n minus 4n, that's 0. So we are left with 2 there. That will be 3 raised to the power of 2. And 3 raised to the power of 2 is what? That's how to simplify this one further. That's how to simplify further. And let's try another one. This one now says we should evaluate. Now we have a big square root now of 8 squared multiplied by 4 raised to the power of n plus 1 divided by 2 raised to the power of 2n times 16. If we evaluate this now, everything is inside this square root. Now, let's simplify. We see most of them. This one is 8 raised to the power of 2, 4 to the power of n plus 1, 2 to this. You see, all these base here, they are not the same, but we can make them to be the same. Because we can express 8 to be a base of 2, that's 2 raised to the power of 3. 4 also to be a base of 2, 16 also to be a base of 2. So that means we can say that we have the square root. 8 is 2 raised to the power of 3. So we have 2 raised to the power of 3. Don't forget, we have a power of 2 there before. So that's a product power multiplied by 2 times 4 is 2 raised to the power of 2. Don't forget, we also have the power there, which is n plus 1, divided by, this one is base of 2 already, so we still leave it like that. Multiplied by 16 is 2 raised to the power of 4. So now this, let's simplify for that. 2 raised to the power of 3 times 2, that will be 6. Times 2 raised to the power. If you open the bracket for this, that will be 2 times n, that will be 2n. And 2 times 1, that will be 2 plus 2. Divided by, this one is 2 raised to the power of 2n times 2 raised to the power of 4. Now, if we simplify this further, and now we apply our law. This is multiplication. We have the same base of 2 here. Let's apply our multiplication law to the numerator. That means what we do is just to add that power. So we have 2, we pick one base, and we add the power 6 plus 2n plus 2. Let's do the same thing for the denominator because they have the same base. Multiplication, we also add the power. That will be 2 raised to the power 2n plus 4. So in simplifying that further, if we add the power, then that will be 2 raised to the power 8 plus 2n divided by 2 raised to the power, I can still write it 4 plus 2n. Now, the base here is still 2, and the operation here is division. So I can apply my divisional law since they have the same base. That means I will pick one base, that will be 2, and we subtract the power. That will be 8 plus 2n. Now, because the powers here are not just single entity, let's put it in brackets, minus 4 plus 2n. So that means in simplifying this further, that will be 2 raised to the power. We have 8 plus 2n. We use minus to open these brackets. That will be minus 4 minus 2n. We don't make that mistake because it's just a single entity. So 8 minus 4, that means I have a square root of 8. 8 minus 4, sorry, that's supposed to be 2. So that means we have a square root of 2 raised to the power of 4. 2 plus 2n minus 2n, that is 0. That means I have a square root of 2 raised to the power of 4, that's 16. And the square root of 16 is what? Is 4. That's the way to simplify it. The first approach here is for you to bring everything to the same base. After that, you can begin now to apply your law individually, either your multiplication law, your division law, your fractional index law, individually. Now you can now apply that law. That's law. Now let's look at one more example. Now look at this now. We are asked to simplify this. That's 75 a raised to the power of minus 2, a raised to the power of minus 3, Sorry, that's minus 2. A raised to the power of minus 2, b raised to the power of minus 2, divided by 5 a raised to the power of 3, b minus 3. Now, this one is a combination of variable a and b. We can say apply our indices to individual variable there. That's what we do. You see the operation here between a here and the a raised to the power of minus 2 and the a raised to the power of 3 is division. The same thing here also, b raised to the power of 2 and b raised to the power of minus 3 is also division. But we can, this one is just number. So 5 can go in 75. So 5 here 1, 5 in 75. That would be 15. So if you simplify that one for that, 5 here 1, 5 here, that would be 15. So that means we have 15. A raised to the power of minus 2, b raised to the power of minus 2, divided by a raised to the power of 3, b raised to the power of minus 3. Now, individually now, because if you see you can now begin to apply our division law to A and also to B. And don't forget our division law, once the base is the same, subtract the power. But don't forget there's some power here at the denominator that are negative. So that means you need to be very careful. 15A, we subtract the power because it's division. I'm dealing with A first. The power of the numerator for A is minus 2. Now for my denominator here, since that will be minus 3 because it's subtraction. Now going to B, the power of the numerator is minus 2. The denominator is minus. Division is minus, but the denominator here is minus 3. You should be very careful. So that puts it in bracket minus 3. This one will be 15. A raised to the power minus 5. B raised to the power minus 2. Okay, now minus times minus become plus. This one becomes plus 3. And that is 15. A raised to the power of minus 5. B raised to the power of minus 2 plus 3, that's 1. So that means here we have 15, a raised to the power of minus 5, b. But now there's still one thing that we can apply, that's our negative index law because of this now. So that means don't forget, I say a raised to the power of minus 1 is 1 over a. Likewise, if I have a raised to the power of minus 5, same thing as 1 over a raised to the power of 5. So in this, I can rewrite this as 15 multiplied by, this one could be 1 over a raised to the power of 5 multiplied by b. So if you just do 15 times 1 times b, that will be 15b over a raised to the power of 5. So that's the way to go about this. When we have multiple variables, that means you deal with them individually. A to A, B to B. That's how we go about it. A to A, B to B. A to A, B to B. A to A, B to B. That's how to go when we have multiple variables. What we just do is A to A, B to B. A to A, B to B. And that's the way to go about it. And that will be the end for today's class. That will be the end for today's class. That will be the end for today's class. That will be the end for today's class.